This video will be going over how to find the volume of a torus by rotating a circle along the y-axis. The first question you should ask yourself is whether you should use washers or discs. Since the donut looks like a washer, I'm going to be using washers. With washers, we have a bunch of really thin pieces that we're going to build from the bottom to the top. In this case, bottom to top. So we only need to calculate the width of the washer. If my finger were a washer, the width of my finger would be the width of the washer, where the outside of my finger is the outside of the washer, and the inside of my finger is the inside of the washer. The red dot would be the outside of the washer. The blue dot is where the inside of the washer is. Once again, outside of the washer, inside of the washer. To find the width of the washer, we first need to find the equation of this circle, which is x minus b squared plus y squared equals a squared. We want to solve for x, so we get the x position of the red point and the blue point. X equals b plus or minus square root a squared minus y squared. The x position of the red spot is b plus square root a squared minus y squared, while the x position of the blue spot is b minus square root a squared minus y squared. The x position of the red is this because, according to the graph, the red spot should be bigger than the blue, which it is. Now we need to find the change in volume, which equals pi r squared times delta r. To find the volume, we take the integral of this, which equals v equals pi integral r squared times dr. In our example, to calculate the volume, we do volume equals pi times the integral of the outside radius minus the inside radius times dr, which is equivalent to pi times the integral of b plus square root a squared minus y squared all squared minus b minus square root of a squared minus y squared. All of that is also squared times dr. You at home viewers should have the pleasure of simplifying this yourself and get pi times the integral of 4b square root a squared minus y squared times dr. Sorry, I just made a small mistake. These two should be dy. Since we are building this donut from bottom to top, our limits of integration should be from negative a to positive a. So our volume should be from pi times 4b from the integral of a to negative a of square root a squared minus y squared dy. The integral of this is rather complicated and requires using trig identities, but I'll explain how to do this integral in another video. But I'll give you the answer anyways. So it's pi times 4b times a squared times pi over 2, which equals pi squared times 2 times b times a squared, which is the volume of the torus. Yay!